This is Mr. Hassan's Maths channel. I'm now answering question number 4 from the October 2024 Pure Mathematics P3 paper from the Edexcel International A-Level exam. And here we have a question about logarithms. And we're told here that the number of bacteria on a surface is being monitored. The number of bacteria n on the surface t hours after monitoring began is modeled by the equation log to the base 10 of n equals 0.35 t plus 2. So we got to use the equation of the model to answer parts A to C. Okay, so we got to find the initial number of bacteria on the surface. All right, so the initial number of bacteria on the surface means when time equals 0. Initial means at the beginning, so that of course means when time equals 0, when the monitoring started. So we just replace the t with 0. So you have log to the base 10 of n equals 0.35 times 0 plus 2, which leaves us with log to the base 10 of n equals 2. Now, what this means is, remember, if we're going to convert from log form to index form, this is the base, this is the power, and this is the answer. So here, this is the base, this is the power, and this is the answer. So therefore, we can say n is equal to 10 squared, which is 100. So n is equal to 100. Okay, so that's the initial number of bacteria, okay, on the surface. Then part B says, show that the equation of the model can be written in this form. Okay, so let's just... So show that the equation of the model can be written in this form. So we have log to the base 10 of n is equal to 0.35 t plus 2. So we've got to show that this can be written in this form. So we got to change it from the form of a logarithm into index form, as we just explained just now. So we can write this as I said, this is the base, this is the power, 0.35 t plus 2, and this is the answer n. So we can say n is equal to 10 to the power of 0.35 t plus 2. So we want to have here just something to the power of t. Okay, so what would we do to change it into that form? We can think of, if we think like in reverse, I know that a to the power of b times a to the power of c is a to the power of b plus c. Okay, so if we think backwards, okay, we have 10 to the power of 0.35 t plus 2. So this is the same as saying 10 to the power of 0.35 t times 10 to the power of 2. Okay, so you can say n is equal to, that's 100 times 10 to the power of 0.35 t. Okay, so our b is 10 to the power of 0.35. Okay, so you can say a is going to be equal to 100 and b is equal to 10 to the power of 0.35, which we have to give into 2 decimal places. So let's work that out. So we have 10 to the power of 0.35, 10 to the power of 0.35, which gives us 2.23872. 2.23872. So therefore we can say n is equal to 100 times 2.24, okay, to the power of t. Okay, so there's the answer for this question. All right, we just had to write a and b. So they want it in this form where you have a number to the power of t. So you can't leave it as this. That has to be a particular number that they want to 2 decimal places, that number b. Okay, so there's the answer to part B. And then part C, it says, hence find the rate of growth of bacteria on the surface exactly 5 hours after monitoring began. So they want us to use the model here. Okay, so find the rate of growth of bacteria. Okay, so we need to find the rate of growth of bacteria. So we have to find the NDT. Okay, so we need to find the rate, how much. It's not the number of, it's how the number of bacteria is changing. So we got to find the NDT. So we should really use it in this form. Okay, so we got to find what the NDT is. So we got to find the NDT. Now, when you differentiate something like this, basically it stays the same first because it's something to the power of t. Okay, so if you differentiate a to the power of x with respect to x, okay, then you have a to the power of x times ln a. That is the rule that we should know about differentiating some exponential functions. So the NDT in this case will be 100 times 2.24 to the power of t, and then times ln of 2.24. Okay, so exactly 5 hours when t equals 5, then the NDT is going to be equal to 100 times 2.24 to the power of 5 times ln of 2.24. And so that will give us our answer. So I can keep this as our answer. I can say this to the power of 5. So I'll put answer to the power of 5. Okay, times 100 times ln of the answer. Okay, that's that number that we had there. And that gives us 4,531. Okay, 4,531.935, which to 3SF, didn't tell us how to round it to 3SF, 4,530, okay, bacteria per hour, I guess, per hour. Okay, so that's per hour. There's the answer, 4,350 bacteria per hour. So that's how we deal with that. Remember, when it says a rate of growth, it's a rate of change of growth of bacteria with respect to time. That's the NDT. That's how we differentiate exponential functions. So that concludes this question, question number 4 from the October 2024 Pure Mathematics P3 paper. Other questions from this paper can be found in the playlist that will appear in this part of the screen at the end of the video. Here you'll find other questions dealing with logarithms, okay, from P3, and here differentiation of standard functions from P3. And you can subscribe to the channel by clicking on this link. Thank you for watching and see you soon.